Strap yourself in. We have Archer and Joby CEOs come face to face in an exciting interview full of important information on both companies. Hi hustlers. Today I'm here for a massive day. We're going to watch Archer CEO Adam Goldstein come face to face with Joe Ben Bever from Joby Aviation, and it's a must see. Do me a favour before we get into it. Hit that subscribe as we release at least one eVTOL video, and I've claimed the most active eVTOL channel here on YouTube. Alright, here we go.
I am joined by three pioneers in urban air mobility. Adam from Archer, Akil from the GCAA, and Joe Ben from Joby. So without further ado, before we launch ourselves into answering our question, if you can introduce yourself. Joe Ben.
Good afternoon. My name is Joe Ben. I'm the founder and CEO of Joby Aviation. It's really a pleasure to be here. Very grateful to the Savi cluster, to Audio, for DMT, and for the entire Abu Dhabi ecosystem for the very warm welcome and the incredible lean in on this exciting new age of mobility. Just heard the lean in from the government here in the UAE is really unprecedented. The momentum on building out infrastructure, the momentum on following on with the incredible work that's going on for certifying these aircraft around the world is really fantastic. The support from all the different areas of the government here in the UAE, and as well as Abu Dhabi and Dubai is just fantastic. And we're seeing increasing momentum with the build out of infrastructure, and I really want to highlight how vitally important infrastructure is and how fantastic it is that the UAE is able to move expediently on the development and the permitting of infrastructure, because that's what's going to make this service really compelling for people, is if you can fly from where you are to where you want to go, and that requires building out infrastructure at critical destinations across Abu Dhabi and across the country. So we think that this is...
Now, I think one of the biggest marketing points in this is the amount of time it's going to save. Both companies are looking at taking 45-minute journeys down to 10 minutes. You go from a bird's eye view rather than throughout the roads. I think both companies need to sell it more as it'll save time rather than it'll be a better service.
A fantastic highlight for how fast and how inviting the UAE is for this new mode of transportation. So we're very, very grateful for the very constructive dialogue we've had with the GCAA over the past 6 years, and the ability to take all the work that we've done with the FAA as we have completed stage 1, stage 2, and stage 3 of our certification process with the FAA, and we're now well on our way with the 4th stage, and to be able to take the groundwork that we've laid there and bring all of that process and all that learning, all the foundation of our certification process. And
now, I'll drop that video at the end. I've done a nice video on why I really do think Joby is going to hit that 2025 target, and we hear from Joby themselves on why they will hit that target.
And bring it here and engage in a really constructive and forward-thinking way with the GCA. So very, very pleased with the engagement and with the momentum we're seeing.
Joben, what about entry into service? You guys plan to operate your own aircraft here in UAE. So how are you dealing with that?
So our target is to launch service here in the UAE before the end of next year.
So if we shift gear a little bit, right? When we talk about electric aviation, we always talk about sustainability. And aviation has a big goal to be net zero by 2050. And eVTOL will be a small but continuously growing piece of this net zero goal. So what are the efforts that your company is pursuing to make sure you're going to have a positive impact on emission, especially consider that you will be using lots of batteries? What is the impact of the grid energy cleanliness on your emissions?
So sustainability is a core tenet of our values at Joby. We have committed to source 100% of the electricity that goes into running our manufacturing facilities from renewable sources. We have also made that commitment for the operations of our aircraft. And so this is critical for the sustainability of charging and operating our fleet, as well as manufacturing our fleet, to deliver the lowest grams of CO2 per passenger kilometer, which is the metric that I like to use as we look to, with every successive generation of aircraft that we build, to become more and more sustainable. And I'd also like to highlight the incredible work here in the UAE, both on renewable energy, but also on green hydrogen and the generation of hydrogen. In my view, hydrogen electric propulsion is a critical unlock as we take the technological breakthroughs that have come with the generation of battery electric aircraft, and we apply them to more and more of the aviation missions. And so I think that we're just at the tip of the iceberg, and the opportunities before us for taking these technologies and scaling them is really exciting. And the work that the Savvy Cluster is doing and the emphasis that the UAE is putting into building the next stage of aviation here in Abu Dhabi is really unprecedented.
And Adam?
Now, the hydrogen project will open up Joby like keys to even more capital. With the electric vehicles, they're only great for small hops intra-city. With the likes of your hydrogen, you could go from city to city, and as you can imagine, the capital there will be insane.
Let's, one more question. So public acceptance. We always talk about public acceptance, and it's really one of the great unknowns for our industry. The majority of the public doesn't know what an eVTOL is.
Before we go into a public acceptance, hit that subscribe. We want some public acceptance.
We don't even agree on how to call them. So how they will react, this community, to this new form of transportation, we don't know. Will they fly on it? And even more important, will they be accepted on being flown over? So I would love to hear from you guys. How are your teams working in UAE this possible issue? And what are you doing to educate the public so that they become a net supporter for this industry as opposed to, you know, what we're seeing maybe now in Paris? Joby.
So I think this is critical. This is one of the most important points as we look to launch the service and scale it. And as a result, as we looked, when I founded the company nearly 15 years ago, I set out safety and noise as the two highest priorities for the design constraints on the aircraft. We wanted to build an aircraft that was dramatically safer than small aircraft today, that was redundant across every system on the aircraft, very similar to a large commercial passenger jet. And we've been really pleased with the results we've been able to achieve there. In addition, on the acoustics, in our view, in order to take passengers where they want to go, in order to get takeoff and landing locations permitted close to where people live, these aircraft have to be dramatically quieter than today's aircraft.
Now that's important. When we're talking about these aircraft, we're not talking about ones or twos. We're talking about an ecosystem of up to hundreds, if not thousands. So we can't have them as loud as your conventional helicopter. And I like the way both Joby and Archer have tackled this acoustic problem.
And so we've spent the last 15 years developing an extraordinarily quiet vertical takeoff and landing aircraft, which we've had NASA come out and measure, where we took and they laid out an array of microphones and measured the acoustics of our aircraft in all of the different modes of flight, and showed that it was dramatically quieter than a helicopter, both in takeoff and land and in overflight. In addition, it's not just quieter in an absolute sense, it's also the quality of the sound. Rather than the low frequency whop whop of a helicopter, which travels long distances and shakes buildings, it has more of the sound of the wind in the trees. And we think that, so it's not just the absolute sound level, but also the quality of the sound, which is really crucial to having people want to have a vertiport close to them. And as Adam said earlier, the value of real estate is driven significantly by its access to new transportation modes, and we think that this will become the most coveted transportation mode, and therefore will have a really profound impact on real estate pricing. And so we're very excited about the acoustic signature of our aircraft and its ability to be welcomed into the communities we wish to serve.
And I have witnessed both their airplanes. And I remember when I see Adam airplane, there was a helicopter taking off. We couldn't hear your airplane. And when I came to see you guys at Joby, I remember it was the first time in my life that I saw an airplane, but I didn't hear it. We had to be quiet. It's like, quiet, listen. It's the opposite of what actually usually happens, that you're like, oh great, quickly. What is the answer from both of you about this criticism? It's going to be a toy for the rich. The four of us know that's not the case. But how do you respond to that type of criticism?
I'm sorry, there was a bit of feedback. I didn't catch it.
In Paris, some of the people say it's a toy for the rich. We know it's not. But how do we go against this understanding, false understanding that's out there?
I think we need to serve communities that want to be served, that are really excited, and you know, to add to Adam's point about the excitement of this, it's not just the notion of getting to fly, it's also the experience of flying. And when you get to get in an aircraft and fly over the beautiful cities, especially a beautiful city like Abu Dhabi, and see it from the air and see it gives you a completely different perspective on your day. And so we're really, really excited to bring the magic of flight to people's daily lives.
I'm here with Joe Ben, and this is Joby, his company. We're going to be talking a little bit about vertical takeoff machines. VTOLs are extremely important in the future. If you ever wanted to have the Jetsons kind of experience, this is step one. So anyways, thank you so much for letting us have a look at your facility. I'm delighted to be here. Why don't you give us a little, I'm looking around, I see a tremendous number of fixturing, things in production, or at least this looks more like production than it does just prototyping. So I'm very impressed. I'd really like you to give us the lowdown on Joby.
Thank you so much. Yeah. Really fantastic to have you here. And so this is our composites final assembly facility. And as you noted, we have a significant amount of fixturing around the facility here. These are tools that we're using to build, we call this our pilot manufacturing line, where our target is to get to parts for one aircraft a month by the end of this year. And as we go through it, you'll see planes in all different states of construction. So behind us, you see a wing going together, and we have tail fixturing, fuselage fixturing. All of this was developed in partnership with Toyota.
Yeah.
And we have an incredible partnership with Toyota. They've been.
No, it's interesting to hear his thoughts on this partnership.
Working shoulder to shoulder with us, both here in Marina as well as in San Carlos, which you'll be visiting this afternoon, to really optimize our processes and streamline and use this as a facility to learn the lessons so that we can get the manufacturing processes right as we look to scale to larger and larger volumes over time.
You know, I think that one of the things that I really like to hear more about is how did you come up with the concept? Just give us a little bit more about Joby, how this all came together. Because quite frankly, you know, one day nobody heard of you, and the next day you're getting the biggest single contract for vertical takeoff on the planet. That would be Delta, correct?
So we've got an incredible partnership with Delta, with the DoD, with Toyota, with Uber. So we're very, very fortunate across all the different pieces of our go-to-market strategy to have amazing partnerships. In terms of your question about the background, this was a dream of mine from when I was a kid to build a better way to get from A to B, and worked on it back in 1993 when I was in college. At that point in time, batteries weren't ready. We were at about 50 watt hours a kilogram specific energy. That progressed through the 90s and early 2000s to the point where we had batteries that had enough specific power for vertical takeoff, but also were approaching 200 watt hours a kilogram. Today we have cells that are over 300 watt hours a kilogram and that also have the power to do vertical takeoff and landing. And so battery technology has been steadily progressing, and that's enabled this new age. And so I formally founded Joby Aviation in 2009 after having dreamt about it and worked on it for many years. Started in a number of other companies that gave me the financial means to kick off what is now become an electric aircraft revolution with recently announced that there were, I think, 1,000 different concepts that people had come up with. So this is very akin to aviation in the early 1900s, where there was like a Cambrian explosion of new ideas, and that's what makes this time so exciting. Is so many entrepreneurs around the world looking at how do we transform the way we move around on a daily basis with air travel. So here's one of the propulsion blades, and so it's carbon fiber with a titanium root sleeve, and this combined with the very high specific torque motor is what makes the acoustic profile possible. You asked how slow do they spin? In cruise, it's as slow as 250 RPM.
250 RPM, no shit.
So
Wow.
we're like a many smaller GA airplanes. You're spinning at like 2,500 RPM.
Yeah.
This is spinning 10 times slower, and that's what makes it so that when you're in cruise and it's flying over, you don't hear the propellers at all. You just hear a whoosh.
Yeah. Well, I saw the how quiet it was when you compared it.
No, this quietness will be quite important around busy urban environments. So it's good to see Joby is utilizing everything he can to make it as quiet as possible.
We'll put a little thing on the bottom that compares yours to, I think it's 5 or 6 other aircraft, helicopters, a Cirrus and whatnot. I will tell you though, this right now is probably less than a kilo, so less than 2 pounds. I'm really impressed. People have shown me their ideas on what to do with props in general, and I don't know how you did it, but well, basically you've got the lower speed, so you can get rid of a lot of the mass that you have to have in order to withstand things.
So this is a titanium part which we print here. This is part of our one of our cooling manifolds, and as you can see, you're able to build a part that's incredibly
complex. Wowzers. Okay, so this is using additive manufacturing. Titanium is one of my absolute favorites for 3D manufacturing and or additive manufacturing. And this has just come out beautifully. This is the only way that you could possibly do something like you couldn't possibly cast it. If you were going to be welding this together, it'd take you forever, and it costs a fortune, and it would be hugely heavy. So I'm very intrigued by the elegant. I love elegant designs, and the elegant design then transformed into an elegant way of manufacturing, and this is just spectacular.
Control surface actuator.
Yeah. A lot of machining. That's for sure. Wowzers. Yeah, these are like you've got them in a display case for a good reason. I mean, they definitely look spectacular. Yeah, and I like the way that you've when companies usually get involved in manufacturing and whatnot, they look at the function, but they don't look at the elegance that you're going to need in order to make things work. And if you have a look here, you can see that there's 2 or 3 risers or ribs, whatever you want to call them, in here to give you the strength, but it's hollow to give you the lightness that you need in order to make things happen, because vertical takeoff eats up a tremendous amount of power. So having something that's been designed like that is the only way really you can make everything work. You have to be looking for every gram of weight savings. So
absolutely,
very impressive.
So let's go over and take a look at the airplane assembly line.
Great.
So this is our final assembly area, where once the airframes are assembled and painted and tested, they come in here, and all the components get put inside. So we have as we just saw there, and you'll see more when you see the facility in San Carlos, all the components we developed are really the heart of what makes this possible. Right. Very high specific torque motors, very light actuators. We design and build all of the power electronics and control systems that go in the aircraft, the switches and all the communication systems, the avionics, and that enables us to build a really next generation aircraft where all the systems are optimally tailored to work together. And you mentioned how challenging it is to build vertical takeoff and landing aircraft. Right. Yeah. That is because you need all of the systems working in perfect harmony. And by building a vertically integrated company, a next generation aviation company, we're able to build aircraft with capabilities from an acoustic standpoint, from an emission standpoint, from a safety standpoint, that really weren't possible before. And so that's what's really exciting here.
Well, I've always been even when it was unpopular, I've been a fan of vertical integration. I feel that as soon as you've got somebody coming in, usually a very expensive consultant, telling you that you've got a core competency, you have to go. As soon as you hear that, you know you're on the path to destruction. So the vertical integration stuff is actually a good example with Boeing. They moved from vertical integration to core competency. What we have to do, and
no, I don't know here if Boeing is a good example.
They, doors fall off and stuff like that. It's very uncomfortable. So I'm very impressed. So you're making your own circuit, because that's usually the thing that people stop. Do you make your own circuit boards then as well?
So
or populate your own circuit?
We design all of our electronic systems, and then when you're up in San Carlos, you'll see all of those systems getting put together.
So how long does it taking now for a build?
We're still a bit.
I mean, in days. What are you shooting at?
we're still over a month. We're, again, by the end of the year, our goal is to be able to build one aircraft worth of parts a month.
A month, so one a month. And so who's going to be the first recipient of your?
Well, so we've already delivered the first aircraft to the first one that came off this line to Edwards Air Force Base. And
is that for testing, validation? Yeah,
exactly.
Yeah.
And then we'll be delivering additional aircraft. We announced that we have another aircraft going to Edwards, as well as two going to MacDill in Tampa, in Florida.
Oh, yeah.
And so really excited about the opportunities on that front too.
Wow, that is cool. So the government is basically your first customer. What about commercial customers? How long before we see I can get a plane ride from Detroit Metro to downtown Detroit?
Well, Detroit's a fantastic example because we have our partnership with Delta, and Detroit is a critical hub for Delta.
It's number 3 on the list, and I can understand LA and New York. Okay, fine, but I will tell you that there's no easy connection. There's no train. There's no trolley. There's no nothing. You take a cab or an Uber to get to downtown Detroit. So this is, to me, this is a gold mine. You'll have to have about 100 of these things where people need to get downtown like right now, and they don't want to take 94. So I'm very excited to see what you're going to do there. Yeah,
absolutely.
Yeah. So how long before Delta starts getting some of their planes? So
with Delta, we are working on building the vertiport infrastructure for JFK, LaGuardia, and LAX. So that's we're working through the permitting process on that. Yeah. And as soon as those takeoff and landing locations get built, we'll be able to start service. The key piece is having takeoff and landing location that's directly connected to the terminal.
Yeah.
Delta's invested $7 billion into.
Now, to be fair, I would like to see a timeline here. It seems like he's dodging it a little bit.
New terminal infrastructure,
right.
And being able to deliver customers directly to those terminals and make it as seamless as possible to get from a Joby flight onto a Delta flight, or from a Delta flight onto a Joby flight, and saving customers time, because that's what this is all about, is making delivering a magical experience.
Absolutely. Basically, nowadays, anyways, time has become even more valuable than the old adage, time is money. And now it's time is everything. Nobody can buy back a second for $1 billion. So, and seconds count in today's world. So this, I think, is just coming along at the absolute perfect time. Okay, so here we are in the cutting line. That's what's going on in back of me. So why don't we describe a little bit about this material and what's going on?
Yeah, so this is what the aircraft starts as. It's a pre-preg carbon fiber from Toray, which is one of the world's leading suppliers of high-performance carbon fiber. And it has a plastic sheet that's on both sides of it for protection. It comes on a big roll, and then this machine here is called a ply cutter, and it robotically cuts out the parts, and then once they're cut out, they get labeled. And
no, I do like to see that this is all done in-house.
And so the machine automatically labels them, and then they get kitted, and then those kits go to the layup room, and we'll go there next and see the technicians laying up the parts.
Yeah, yeah. So we were just talking about the offal, the stuff that goes away. It's kind of like scraps. And we were just talking. One of the things that BMW on the i3 did was to take the scraps and figure out how to utilize the scraps so that they could make non-structural types of components out of what was left over. Because it's very difficult to turn this into something else.
That's right, exactly right. And that's one of the other pieces that we'll see is the AFP robots, automated fiber replacement robots. And one of the beauties of them, not only is it more automated, but it also has dramatically less scrap.
Yeah. So why don't we give me a little explanation of what's going on here with the placement machine?
Yeah, so this is our AFP, automated fiber placement robot. We have two of them. This one is laying up a wing skin, and so it is applying the carbon fiber toes directly to the part. And because it's automated, it's very, very precise in the way it places the fibers, and it has dramatically lower waste. So it's laying individual fiber toes down onto the part, and in a very, very precise way.
So after the toes are put in place, what happens then?
So then the parts gets bagged and put in the autoclave and cured. So once the composite parts have been laid up, they go in the autoclave, and they are cured at high temperature and high pressure. And then when the parts come out, they get debagged and then demolded, and then the molds are prepped to make the next set of parts. So the autoclave gives us extremely high compaction and really high part quality, very consistent performance. And so that's what you see here.
Well, that is a very big autoclave. I got to tell you, I was when looking at the door and whatnot, I was very surprised. So, but you've got, you're just right at the beginning of the production operations and whatnot. Are you going to use any more? Are you going to need any more of these things?
Yeah, so we'll need a bunch of autoclaves. So here you see we've got 3 autoclaves of different sizes here. Yeah. This again is our pilot manufacturing line. As we scale it up, we'll have multiple autoclaves to keep up with the production, even when we're running all the shifts.
So are you looking for those autoclaves like right away, or are you?
Yeah, it's a progressive scaling. So we're a very opportunistic company where we, if we can get amazing deals on equipment, we we'll purchase it. Yes. But also, when you buy secondhand equipment, it allows you to shorten the lead times. Right. Some of these assets have multi-year lead times on when you're looking at building new ones. Always looking for good deals. This is where we take all the components of the aircraft, the propulsion stations, the batteries, the communication systems, the flight computers, the actuators, all the systems on the aircraft. We put them in the lab, and we run them all. And so we've got a cockpit over here. So the components think they're flying. All the software is the same, and we're able to test lots of abnormal conditions, lots of failure modes. This lab is designed so that we can exercise the plane very quickly in rapid succession, go through one failure mode after another.
I'm impressed all the way around.
Urban air mobility is a rapidly evolving space, and many companies are entering the market, but one company that's been around for quite some time looking at this unique prospect is Joby, and I'm delighted to have their founder and CEO, Joby Aviation, here. First of all, it's great to have you along. Can you give us an idea, for those who don't know, what the Joby concept is?
So we're building vertical takeoff and landing electric air taxis. These are fast, quiet, and affordable ways of flying to your daily destinations.
Now, affordable is the key thing, because everybody wants this to be something that we can all use, a price point that's good for everybody. I think when it enters the market, clearly it's going to be.
Now, if we look at the likes of Tesla entered the market at a high price point and then worked their way down. This is sometimes the best way to do it, as your margins are quite high at the very start.
At the higher end of that market, because it's got to start somewhere, correct?
Yeah, so we look at this entering the market at prices comparable to what you pay for a taxi in a city like New York or London, and so that's at a little bit of a premium price point. As the manufacturing volumes go up, as the utilizations go up, we want to bring that price point down and make it more and more affordable over time.
Now again, I do feel like having a nice high price point at the start is good, and keeping the margins quite high are nice. Saying you're going to drop the price is good for the consumer, however for the business, especially when you're in the aerospace industry, do you really want to be pushing prices down, especially when you're only ever one accident away from a massive insurance claim?
So that it becomes a daily mode of transportation.
When any new concept comes on, the public have to get on board, and something like eVTOL is not so out there because we have helicopters, so we're used to vertical takeoff and landing, but it's a very different idea, particularly with the electric side of things. So how do you get the public on board, and how do you start appealing to the public more?
One of the things that's really remarkable is when people get to hear our aircraft for the first time, they get an understanding of how hard we've worked to change not just the quantity of the noise, but also the quality of the noise. And I think this, many people think that, if you make an aircraft electric, it automatically becomes quiet. That's not the case. You actually have to do a lot of really hard engineering to take the acoustics of the propulsion system, not just the motor, but also the propellers, and to make it significantly quieter. And so we brought the acoustics down to the point where in hover, we're at about 65 decibels. In overflight, we're at about 45 decibels. And so what this means is that we can blend into the background noise level of the city.
And what about other use cases as well? Because we know that if you want to appeal to the public, sometimes there have to be some other applications, like maybe medical or something like that, something that has a service outside of just transportation.
For sure, there are numerous opportunities to provide incredible public good, including saving people time.
And what about the training?
No, I would have liked him to expand a little bit more on this, just because I feel like he's just going off the reporter's question. It was a bit of a bluffing answer.
Pathway for when you start going to commercial use, and I can get on a Joby craft. What's the training pathway going to be like for pilots and ground crew?
Yeah, so we start with a commercial pilot, and we put them through a training course to give them a type rating to fly our aircraft. We are also training new pilots, and we've already set up a training academy to do that.
What about something that's fairly unique to Joby? This is pioneering hydrogen electric combination. How is that going to affect what you can offer that's going to be different to many of the other companies out there?
Yeah, so we're starting our operations certifying our battery electric aircraft, and this is an incredible solution to provide services in and around metropolitan areas. Our battery electric aircraft can operate on routes of up to 100 miles, and gives us the ability to fly, for example, the airport to city center routes. With hydrogen electric, we just demonstrated a 523-mile range, and so what that does.
Now this is massive. If they can get also on board with the hydrogen industry, it's a game changer.
This allows us to connect cities and whole regions where, what if you could fly from here in London to the Alps or the Mediterranean? If you're in the US, what if you could fly from Boston to Washington, D.C. or Washington, D.C. to the Carolinas, connecting whole regions together?
And it's also key, isn't it, that you talk about these short hops. We're talking maybe Farnborough to Heathrow, Farnborough to Gatwick. You could do these little inter-airport hops. The longer range gives you London to Manchester. You could do that very simply, very easily, with this range that the capacity you have. It's a no-brainer, right? So that then, when we talk about levelling up in the UK, that then brings regions together and removes the time. What sort of time, I don't know if you know the answer to this, would it take to travel, say, from somewhere like where we are now in Farnborough to Manchester, say a 200-mile trip?
So our aircraft flies at 200 miles an hour.
There we go. There you go. We're not even going to do the maths for anybody, so you can work that one out. Anybody sitting on their motorway when they're trying to get to Manchester would know that that's a considerable time saving. So look, it's very, very exciting. Just for yourselves, when are you expecting to see?
Now, with a trip that long, I would like to sort of know the charging time for the battery. That would be quite an interesting thought.
Your offering come into the public domain?
So we're planning to launch our commercial services next year.
Yeah.
This last year we delivered our first aircraft to the DoD at Edwards Air Force Base. We're delivering another one later this year and 2 more to the DoD next year in Florida. So this is happening, and it's happening today. It's incredible. I've been on this journey for 15 years, and to be right at the start of the commercial operations and to realize my childhood dream of taking our species and moving us into the air for daily transportation is just phenomenal.
And sustainably as well. Look,
This eVTOL evolution is going to happen in 2025. Guys, check out this video to see why I know that's the case. Alright hustlers, peace out.